Good morning and afternoon, everyone. Welcome to our weekly Fast Track Hangout with Matt Nichols this week. I'm Wayne Griffenberg, and we're going to have Matt join us this week to go over what he's done to program the Haas UMC-750. Hi, Matt. Welcome.
Hey, thanks for having me.
Absolutely happy to have you here. So we're going to go through with Matt. Before we do, I just want to let you guys know that we still have a week left that we can vote for your top classes going into Autodesk University this year. So that gives us until the 16th, June 16th, to be able to vote. Okay, I'm going to ask just a few questions for you guys to get an idea on who has been to Autodesk University. Let us know. If you haven't been there before, let us know, and we can get you more information on how you can join. This year we had, in our Instagram challenge, Kurt Chan had opened up an Instagram challenge this year in Fusion to create some fixtures, and we had Makers Inc. that won this year, and he won a ticket to be able to join us and get out to Autodesk University. It's a great seminar, as well as live classes, hands-on training you can get at Autodesk University. So if you haven't been there yet, I highly recommend signing up. So let me close out this vote.
So while we're looking at that, if people don't understand what Autodesk University is, it's not a physical place. It's hosted in Las Vegas every year, and it's 3 days of workshops and class hosted by power users for users. So it's a yearly event conference where users teach other users.
And this year it's going to be widely CAM focused, as well as all of our design tools. So it's a really great opportunity for you to join in Autodesk University to get more education and being able to experience and meet some of those power users. So it looks like we have a good amount who'd like to get there, so we can get you more information on how to get there, how to sign up for Autodesk University on the website. It looks like we have some who are making some parts, and that's awesome. Go out of here, and I'm going to ask one more quick question for you guys. We'd like to know what's most likely to drive your growth when it comes to working with HSM or our CAM inside of Fusion. So as you're working today and using the tools, where are you able to grow with our software? Where can you give us feedback to let us know that we can help our developers know where to focus to drive those tools inside of our interfaces that'll help you out? Again, we really appreciate this feedback. It also helps us to drive the content each week when we do these webinars, what you guys are looking for to learn and an experience where we can help provide some information there, including this one with Matt today. All right, so we're going to close out that vote. We do appreciate your guys voting. So it looks like there's a lot of people that are looking for some true 4 and 5 axis. Al, I think that we've seen some drivers before, mainly with 2 and 3 axis, but we're starting to see more people looking for 4 and 5 axis.
I would hope so. The title of this webinar is running a UMC-750 with 5 axis, so looks like we attracted the right crowd for today.
Awesome, guys. Thanks for voting. And so, without further ado, let's bring up Matt. Matt, if you're ready, you can walk us through how you programmed that part on the Haas UMC for this year's demo days.
I originally started working on programming this part, and we were going to run it in the latest Kansas. That's your NIMAT, H2O NIMAT. Me and my buddy Mike were programming it. He's an application engineer there. Reached out to me and wanted me to help program a part for the UMC for demo days. So we started working on it. I ended up showing an application engineer at the HFO in Denver, and they were also interested too. So that's why I came up with a tale of two cities, because we had OLED Denver. One was running in steel and runs one in aluminum. So here was the setups that we had. Mike actually created this workholding. He created the base and everything, pulled the connections for the flange here, and then also this little clamping piece on the top as well, which really worked really well. And then in Denver, we ran it on a 5th axis vise. So to begin with, whenever we started looking at programming, we had this little list of tools, and this was a list that Mike had. So we came up with our tool list, built it all in Fusion, and then I sent it to the Denver guys so they get their tooling as well. So we were literally running similar tooling, even though we're running steel in Kansas and aluminum in Denver. So they had more 3-flute, and we actually used some 5-flute tools. Yeah. So then this was a stock part that or stock piece that we started working with, and prior to the demo days, Mike had actually gone through and done the opposite side of the part where we were actually clamping it down to the work holding so we could machine out the rest of it. So with that, here's what I put down covering today. I want to cover parameters and text inputs to control values, so more or less my height planes, and then my actual depth of cut. We're going to look at 4th axis wrapping and different ways that we can use it. Patterning, 5-axis warping, and then one that's kind of important that goes with the 4th axis wrapping is using STL files for rest machining. Okay. So with that, let's go ahead and dive into Fusion. So here's the setup we're going to look at. So as you can see, I've got 5th axis 5. I come in here to my setup. I'm working with 7-inch diameter stock at 4.5 length. So that's also including the dovetail at the bottom. Okay. So to go in and start programming this, the first toolpath I did, I wanted to get here out around the top here, just to begin this first toolpath. I grabbed my 5/8 bullnose end mill. I've got 1 inch and 5/8 flute length on here. Okay, so on this one, what I want to do is I'm going to run it at 130 inches a minute. I'm going to do my lead ins a little more than that. Okay, so for geometry, what I want to do is I want to leave it with no selection of my geometry, and then I'm not even going to have rest machining on. I'm just going to leave stock contours. Now, for my heights, what I want to do is I want to make sure my bottom height is, basically I want to control it by my flute length, okay? And I don't know if, how many people out here know this one, so this is one of the tricks that I wanted to show. And I actually have to go into Inventor here in a second. So typically what you can do in here, in these text values, is I can hold down Shift and it'll show me parameter names. In Fusion, it doesn't actually work in the tool library. So if I come over here, now in the flyout at the bottom, you can see the parameter name of that value. So the cool thing is, and I know not everybody is using Inventor, so what I may end up doing after this is actually posting like a small list of like the tool parameters on my blog, so everybody can go on there and look at it. But anyway, so what I want to do is I want to control by my flute length. So if I go back into my toolpath in my heights tab, I'm going to come in here and I'm going to say from model top, and then I'm going to put negative tool underscore flute length. Okay. Now, I know with that, and I know I've got a little bit of extra space between where my flute and my actual collet is for the holder. So whenever I do this, since I've got that bull nose, that's not going to give me a flat edge right at that line that I'm wanting. So then what I'd also want to do is I'd also want to add basically my corner radius as well. So in this case, I know it's 30,000, so I'm just going to add 30,000 to that as well, negative. Okay, so I'm going to let that calculate. Oh, actually I don't want to do that yet. So you can see it was actually going on the inside. Basically on this operation, I just wanted to cover the outside. So if I go into my passes and hit machine cavities and turn it off, I can hit OK, and then now I'm going to get the outcome that I want. Okay, so that gives me a roughing of the outside. So I've got 20,000 still left on perimeter here on these faces, which we'll come back and get later on. All right, so that's the first step. Now, the next one is the fun one. So now we're going to look at the actual fourth axis wrapping. So a couple of things I want to show is whenever I come in to do a fourth axis wrap, there's different ways that you do them. Okay, so a lot of the examples you'll see are parts like this where it's got a pocket that has a beginning and end that you can see. It automatically selects it all easily. But what we don't look at a lot is how do we work with a profile, basically, or a pocket that doesn't technically have a beginning and end. Okay, so here's a couple ways that we can do this. One way is I'll actually create, and I'll actually show you this so you can see that I'm not just like crazy, which is possible still. Anyways, so I'll pick my face that I want, or my diameter that I want to wrap the tool around. Now if I go in and actually pick the pocket here, you can see that it just picks that edge, and now I have like a red perimeter around it. If I hit OK, I can get this warning. Ground unwrap sits with geometry. Okay, so here's how I go about doing this. I'm going to hop over to my model side real quick. And what I want to do is I just want to create a plane that's tangent to my cylinder. Okay, so I'm going to grab this face real quick, and then I need to pick a reference plane as well. I'm going to come in here to my origin. All right. Grab this plane. All right. So now I got that plane built, and I'm going to create a sketch on it. Okay. I'm just going to do a center rectangle. Then do project that edge. All right, and then I want to do a linear constraint just so it stays on that. Now the cool thing about doing this is since that center point is right in the center of that pocket, I do that linear constraint, it automatically snaps the proper width for that pocket. So then all that's left is to actually fill out the length of it. So I know I've got a 4-inch diameter cylinder where that is. So I'm just going to do some basic math of 3.4 times 4. Okay, so that gives me 12.56.
Now, you're bringing us back to math class. Why did you put 3.14?
Pi times diameter.
It's pi. You have 3.14. So he's calculating out the circumference of the circle. The other thing I wanted to bring up here for anybody that's not doing it already, all of our CAM products run inside of parametric tools. So again, if you're HSM, Works or Inventor HSM, same kind of thing. Matt is intuitively capturing his design intent while he's working. It's always something you want to do when you're using a parametric tool so that when changes happen, the tool path and everything updates in the way that you want it to update. So, I'm noticing you do that sort of intuitively, and that's the kind of thing that the habit we all want to be in as we're modeling and as we're programming.
Yep. Yeah, absolutely. So this gives me the 12.56. Now, I'm going to add just a little more to it, and I'm actually going to take out all this. So that 12.56 gives me just a reference number, but I want to make it larger just so I make sure I have overlap so that I get all the material clear that I need. Okay, so I'm just going to bump it up to 3.25. So now with that, I can come back over to my CAM side, and then again do my 2D adaptive. Come over to my, let me make sure I have the right tool. Yeah, okay. Come over to my geometry tab, pick my wrap tool path, pick the cylinder. Now for the pocket, I can just come in and I knew it was going to do that to me. And another thing I forgot. So one thing, I haven't figured out why it was doing that to me. Whenever it does that sketch, it wants to actually select this geometry that should be construction, so it shouldn't actually do it. But since it is, I'm going to go ahead and delete it. Give that dimension. And then just for my safety's sake, actually do this. Tumble driving. Okay. So another thing you can do with dimensions, since I lost that whole the center point rectangle part, I don't want that to be turned dimension. There we go. Okay. So I'm gonna hit that. I'm gonna hit this. Yes. All right. So now this gives me a driving dimension here. I can go back in and modify this dimension. Pick that. Divided by 2. So it'll always reference that dimension and it'll divide it by 2 every time. So I still get my parametric side of it. It's just not the way I wanted it to. Anyways, all right, so back to the CAM side. All right, again, do the adaptive, geometry, wrapped. All right, now I grab this pocket. Then what I want to do is I want to tell it multiple depths because I only want to take about a ½ inch step all the way around as it goes down. But I'm still taking a ½ inch step over, so I'm still removing quite a bit of material in one shot. And then my heights plane, what I want to pay attention to here is I want to make sure the top is still at my stock top because I still have the material on this edge up to here. So I want to make sure I account for all that. And then I'm just going to hit OK. And then we get our awesome wrapped toolpath. You can see it overlaps just a little bit enough to get all that material there. Now, here's the next question. Let's say we have an open pocket like this, but I have something more along the lines of this as my geometry for that pocket. So we use the same process, except for I don't have to create a sketch on this one. This one's a little bit trickier, and I'll show you why. So if you can see on this part, you can see these little split lines. So this was my workaround kind of being able to select these pockets individually as well as having them overlapped so I can get complete pockets. Now the one thing with this one is that even though I did this and I could overlap the pockets, I can't select both sets of geometry at the same time. So I actually have to do 2 separate toolpaths, which is ironically what we did whenever we ran the part at demo days. We had 2 separate 4th axis wrapping toolpaths that drove it. So if I come over here and look at this is the kind of geometry or toolpath we had. So if I come in and actually look at this, you can see that with splitting this part, I was able to select this contour that wrapped around to a certain point. And then what you don't see, or it's kind of hard to tell, is there's actually 2 parts. So I've got this one, that's the split, or it says other split, and this one that's edited. So they both are overlapping each other. So I use one for one split and one for the other split. So I get that's how I got my overlap, was by doing that.
Yeah, that's good. As a product manager, it makes me sad that you have to do it that way, but at the end of the day, people need to make parts, and it's good to know that you can use the modeling side of Fusion. It's correct to be able to use the modeling side and make the software do exactly what it is you want. You're hitting on some excellent points here, Matt.
Awesome. Yeah, so that's how we go about putting that wrap toolpath around where these ribs would be. So it actually turned out really good for the size that we were on, or for the parts that we ran that had the ribs. And it was actually really fun watching it too. So that's how we create those. So that's how the difference between seeing something, a pocket that has an end, and beginning and end, whereas if you have like a cyclical face, how you would go about controlling that. So we got this one. Now what I want to do is, and this one was kind of fun, so I remove all this material here, and I want to go finish this pocket, but I still have that extra material on the top here. Okay, so I want to do a real quick operation just to be able to go in and finish that contour. Okay, So if I go back in here, I got a sketch in here. So another sketch I created to do a 2D contour wrap, which, you know, you could do a pocket one just like this as well, but I decided to do a 2D contour on this one. So I'm going to do wrap toolpath again, pick my face of that inner diameter, and then I'm going to go over here and pick my contour. Okay, so in here what I want to do is I want to make sure I'm actually machining from this side out, because, you know, I don't want to hit my vise, so I reverse my arrow on the line. And then what I'm going to do is I'm going to come over here to my passes tab, and I'm going to tell it I want to do roughing passes. And I could probably do a better step over, but I'm just going to do a 60th step, and I'm going to do 6 passes. All right, now this is where my other models come into play. Pop those on, pop that on. All right, so here again, I have to pick the 2 split lines, and I have both those models in here as well. So that's going to be part of some of the other stuff I'm going to do. So I have those split lines, so I have to pick both those contour splits to just get the full wraparound, but once I do that, it works really well. So then I get a full wraparound. Alright, so now what I can do is, since I've got those 2, now I'm okay to go in and finish that pocket. So here, I'm just going to do a derived operation, a 2D pocket. So the cool thing with that, the geometry, everything that I wanted is already selected for me. The only thing I need to do is come in and turn off stop to leave and local depths. Actually, I'm going to change that too. I think I did 60,000 step overs. Yeah. Then you get this nice little pattern. So that's how I went about doing the forward axis wrapping on these, and it turned out great. So let's do, since we got that, let's do a simulation real quick. Okay, and then ceramic. All right. So I'm going to go ahead and do simulate. Speed it up some. So the fun part about this, so right now my run time is at 16 minutes, and that's actually pretty close to what it was for just these operations. Okay, and then once this is done, it should be in a second. All right, so now at this point what I want to do is I'm actually going to right click, and I'm going to save this stock, and we're going to use this here in a few minutes in an operation. You'll see what we're doing with it whenever we come there. Okay. All right, so we got that.
I'm just going to address a quick question here from Ben while it's on topic, because I think you're moving on to another topic now.
Yeah.
Ben's asking if eventually we're wanting to handle cyclical wraps or wrap cycle all the way around in another way. The answer to that is yes, Ben. When we were first working on doing wrap geometry, we had a discussion with the kernel team trying to decide how we should prioritize the work. They do have a thought, an idea for how we could write a kernel that understands these sort of cyclical things and makes intelligent decisions, but we chose to get product out and understand that there would be a shortcoming in these situations. We're not working on it yet, but we have a solution for how we want to solve it. It's just a matter of prioritizing that work with the other work. So hopefully that's a sort of a long answer to a short question, but I want to be transparent about how things work. It's good to see Matt show how to work with what we have. Love to hear from you, all of you, how you would prioritize this type of situation. Floor is yours again, Matt. Thanks for letting me have the interruption.
Yeah, no problem, anytime. Cool. So, so the next place I wanted to go in this is addressing basically these different pockets or the drilling locations. So, the first thing I want to do is I want to go ahead and actually work on this pocket. And actually, real quick, one thing I need to do is a 2D contour. And turn off these two. That's that one. Alright. So here I want to go selection. I got a quarter inch 20 on that. Whatever. Alright. So I wanted to go ahead and do a finish toolpath around that face. Okay. So with that, now I'm going to go ahead and start working on these pockets. So here's one thing to keep in mind. Okay. So I'm doing adaptive. I'm going to actually drop down to a half-inch tool. So I'm going to go to my geometry tab. I'm going to do tool orientation. I'm just going to grab the bottom of this pocket for my Z. Turn stop contours off. Now, what I want to do here is I'm going to do my selection for my machining boundary because I only want to do this pocket, right? And I do want tool to go center. Actually, I'm just going to go ahead and say outside. Because what I would like it to do is kind of start outside and work its way in. Okay. So now if I hit rest machining, and I'm going to go from previous operations, here's one of the things that to keep in mind, and this is one reason why we did the stock STL. So if I come in here and let it do the calculation on this toolpath, notice I'm getting the helix in, and then it's adapting and getting all the rest of this. Plus now I've got this warning. Okay. So here's one other thing that with the fourth axis wrapping that I had to kind of finagle. So it ignores the material that's been removed from those operations. So here's where that STL comes into play. And this is one of the things that's great in Fusion. So instead of on rest machining from previous operations, I do from file. Now from file, if I come over to my Windows Explorer, desktop, properties. So in here what we have to do is we have to actually put the location of the file. So it's kind of cool. Grab that, grab the name, hit OK here. Now, here's the cool part. It almost did what I wanted it to. Hang on a second. Now it did what I wanted it to. So I give it a little offset out, and then it starts on the outside and works its way in. So that's how, and then now you can see I don't have a warning about rest machining because I'm using that file, so it's just reading from the STL file directly. Now, if I'm looking ahead in what I'm actually programming later, you can see that I've got these little staircases, and they're kind of big. So whenever I come in with my swarfing operation, I'm going to have those staircases I'm going to have to deal with. If I wanted to minimize that a little bit more, one way to do that is if I go to Passes tab, you have your maximum roughing step down, then you have your fine step down, which if I look at the expression on it, is basically derived from my maximum step down distance. Okay. So on this, if I just wanted to give it a generic number, I'm just going to do like a 60,000 step. Yeah. So now I get more stairs up. So I'm going to have a little bit less material to have to deal with whenever I come in and swarf. So I want to keep that.
You can, just as a little trick, while you're getting your next stuff preview, you can also do that trick in reverse. So if you want to remove all of that, that's sometimes noise when you're cutting a prismatic part, just make your minimum and maximum step down equal.
Yes. That's very true. Cool. So I'm going to clean some of this up real quick and add it to a folder.
I like this trick. See, so as Matt got chunks of work done, it's a good way of sort of mentally putting that in a folder and saying, I'm done with this. It's ready, and you're going to have a nice little clean way of checking that part of it off. We often talk about how machining a part, how you go about machining a part, and as machinists, you look at the part and you attack a small piece of it, and then you attack the next piece of the same kind of things. How do you eat an elephant one bite at a time? And most complex parts to machine are simply of attacking one part of it at a time, and folders are a nice way of organizing your sort of mental model for how you attack the part. So nice to see you do this, Matt.
Cool. Yeah, and so the last thing I'm going to do is protect them so that I don't lose the actual toolpath. So if I went and changed geometry, it would make it dirty again, so I don't have to regenerate it again. So I'm just going to protect it real quick. I'm going to collapse some of this so I can kind of clean it up. All right. So we did the adaptive. The next thing I want to do is I want to come in and I want to actually put a finish on this pocket with a horizontal operation. So again, I'm just going to hit the horizontal operation. I'm going to grab my fixed flat. I'm going to go to my geometry tab. For my tool orientation again, grab the bottom of the pocket. Now, so the next one on this is I want to make sure I limit my height so that I get exactly where I'm wanting it to go. So I'm going to grab the bottom of the pocket for my bottom height, and then for my top height, I'm going to select the top face here, and I'm just going to go negative 10 thou basically. So then that limits it to only picking that face. So then now that I have a finished surface on here, I'm going to go in and I'm going to do a 5-axis swarf real quick. Let's come in, I'm going to grab the 3/8 again. Alright, so a couple different ways I can do it. I don't know why it's doing this on me. You have your different driving modes. You have contours and you have your surfaces. So one way I was doing this is doing contours and doing manual selections, because I don't know if it's the model and how it was done. It just did not like how I was selecting things, especially if I went to surfaces and then go to faces. I get this crazy thing. So something in the model is just making it kind of screwballed. So I go to my contours, and I go to manual, and then I would just come in and individually pick these lines. So one quick note on this is whenever you're doing this, and I found this out almost the hard way, whenever you're picking the contours, always pick the bottom line first and then the top, because basically your first selection drives the bottom of the tool, and then your second selection drives basically the top of the contour too. So, and your bottom is always blue, top is always orange, or yellow, whatever it is. Okay, so now once I do that, I always keep my synchronization mode to constant slope. It's just personal preference. And then I also did multiple passes. So I did 2 passes at 60,000 step, just because I wanted to make sure I had a decent finish on it. And so that's what I would get. So now if I go back, and I'm just going to grab these 3 real quick, I can come in and do simulate. Now, you can see I don't have all the other stuff simulated, but if I can right click, go to stock and load stock, grab that 4th axis wrapping. And then let it simulate on that. So now real quick, I can take these operations because I have them already, I have the pocket set up. The last thing to do would actually be doing the chamfered edge. Let's come in here and grab this 3/8 chamfer real quick. Grab this contour. Another little trick, whenever you hover over this, you can see that it grabs basically a closed contour of its own. Hold down the Alt key and select individual lines. We're going to tool orientation first.
I think you just did tool orientation maybe for the first time on this one. So for those of you that don't know, tool orientation is a way to do positional floor axis.
Right. Well, I did it on the adaptive and the horizontal.
That's right. My mistake.
I just forgot to on that one. That's why I wasn't doing what you wanted. But anyway, so Alt key, and I can individually select them or double click on the line. It'll give you the option to do open or close loop. I rather hold down Alt key and pick them. Anyway, so I do that. Go to passes. I'm just going to do a little offset down. Cool. So I can take these now, and we're going to protect them real quick. And now what I want to do is I want to do a circular pattern because I've got that many, I think 6 pockets wrapped around it. So that's the last time I want to move it. So if I take those, I highlight them all and I right click and I say add a new pattern. Come in here and select circular pattern. Grab the axis. You can see it starts generating. So now what I want to do is I want to put 6 in there. So now I've got 6 pockets. And then I do want to order by tool. So in here I have preserve order, order by operation, order by tool. So I'm just going to do order by tool. So that I reduce my tool changes and I'm going to OK. And there we go. So the same thing to be done, once I do the drilling, tapping, and the circular cutout in here. I can either do it within the same pattern because I can activate what folder is active. So if I do any toolpath now, it's going to automatically populate to this pattern. So that's one thing. If I didn't, I left this active, it would create it outside of it. So if I do a drilling operation, let's go ahead and grab our 3/8 drill. Geometry, again, tool orientation, pick top face. Then here what I can do is I can just go in and grab that bottom, that bottom diameter. Now, it's going to basically, it's starting the drilling right at that contour, but I want it to actually start up here. I'm just going to come over here real quick and select that top face as my whole top. Okay. And then this is drilled through. So if you notice down here in the bottom height, drill tip through bottom. And then I'm just going to throw in 1/8 inch.
I'm curious, how does everybody like the new preview of the drilled holes?
Like it.
Matt, we may have lost audio. Just while Matt's doing that, one other quick comment I've made a note of. Matt's doing wrapped features on a 5-axis machine. It might not be completely intuitive, but when you're using wrapped features, it does not have to be wrapping around a physical axis. Obviously, if you have a 4-axis machine, you need to wrap around the physical axis that you wrap. But on a 5-axis machine, that axis you're wrapping around can be virtual, and it'll produce 5-axis motion on the machine. The toolpath is just wrapped around an axis. So it's good to know that if this part were off-center on that platter, this 5-axis machine, you can still use a wrap toolpath. You would just be getting a 5-axis code.
Yeah, and I saw Keith mentioned about the leads on the 3D adaptive. Yeah, they were pretty crazy, so there's a modified one. Cool. So let's see. Make sure. Oh yeah. Here's another one. All right. So let's say we were done with all this. I mean, obviously we're not. There's a lot more to be programmed in here. But real quick, I wanted to show, if we say we wanted to do swarf in here, or even do it on our adaptive toolpath in here. Let's just do that. So if I come in here, again with my 5/8 bull nose, this time I'm gonna limit my selection, or where it's actually gonna go within this boundary, and I'm gonna turn off stock contours. Let's do from previous. Nothing's been removed, but just want it to be there. All right, so passes again. I'm going full depth. I'm going to do a 60th step over, and I go into my linking here again, minimum retraction. My stay down level, I typically put at 50% now, kind of because of Al's webinar last time. Actually opened my eyes to the whole stay down deal. Anyway, so 450 on non-engagement. On the Helix, so this is where I like to have a little bit of fun. So one thing that I like to do with our Helix entry into, or helical ramping into the pockets, is we do awesome with tapered helix, and I just love being able to show some of that stuff. So on the ramp angle, you can leave it at 2. Actually, I'm going to, but over here on this taper angle, typically I'll put it between 3 and 5 degrees, kind of depending. This is a pretty deep pocket, so I might do more, so I might just put it at 5 degree. Yeah, so then once I do that, I feel okay.
I think what you, in my last webinar last week, when I told you that HSM makes use of all the cores of the workstation, Matt, we're hearing your workstation fan fire up when you calculate toolpaths. It's kind of exciting. I think it was Jonathan pointed that out.
Yeah, I saw that. I thought that was funny. Yeah, it's, anyways, definitely is taking off. So a couple different things here. You can see that I didn't pay attention to my heights, and it went clear through the part. The other thing I wanted to show here is you can see these little loops where it's actually trying to loop into where these holes were drilled. Okay, so a couple things we're gonna modify on here. Our heights, for one. Again, here I'm going to go model top, But then I'm going to put that, this time I'm going to actually do body length. Body length plus 30. And then the other thing I wanted to do is on one of these here, I've actually got a surface that I revolved around to kind of plug those holes. So if I go into my model right here, you can see it's got include setup model, and I want to leave that checked. But now what I want to do is I want to actually grab that surface that I created right there. So now you can see, since I included that surface, it's not trying to dig into those holes at all. It's just giving me clean cuts all the way around. Yeah, that's a very good point, Keith, that you brought up. You can do, if I come in here and edit, there's this option for shaft and holder in here. If you do, well, actually you don't have it on adaptive. Depending on which toolpath you're using, the 3D Pocket will have it. Usually
the roughing operations don't have quite as many options, but they will still make sure you end up with a toolpath that's aware of your holder.
Right. Okay.
Pull away works, as Keith said, pull away works quite nicely.
Yeah.
Yeah, you can't completely skip passes on a roughing operation, so that's why we don't just look at the options not there.
Yep.
By the way, Keith, thank you. And for anybody else that wants to add, we try and keep these webinars as sort of as open a discussion as possible. So Keith Clausen's one of our power users who actually I think has a UMC up in Canada, and he's in the comments here giving some suggestions. So please, all of you, use this time when you're live on the webinar to engage. It's very helpful.
Yeah. Cool. And then the other thing I can do, this last thing, will be doing the swarf. So here again, since I've got this surface, I'm going to go into my geometry, and I'm going to grab it. So here it automatically sets my contours for me. Constant slope. Now, here's one thing. If I was to go ahead and OK right here, without even paying attention to it, I'm not going to get the toolpath I want. It's going to go through the part. And that was because whenever I selected it, the arrow is on the opposite side of my lines. So if I just flip it to inside, hit OK, now it's good to go.
And the reason for that is Matt was driving that off of his surface body, and a surface is not, unlike a solid, there's not a definition of what the inside and the outside of the surface is.
Yep. Cool. That's basically all I had to cover for today. Is there any other questions or comments?
I think so I'll just start with a quick comment, and then we can open it up for questions. I'm seeing lots of good jobs, and I learned lots in the questions. I like how you worked for Autodesk, Matt, and you were very willing and open about acknowledging some of the things in the software that it doesn't do super well today, or you have to strong arm it a little bit. We have to recognize at the end of the day, customers have to make parts. I think you did a great job this week showing what the software does well, and showing some techniques you can use to make the software do what you need it to do. So on behalf of product management, there's many things I wish the software did completely, but when it doesn't, we need to make sure our users can still make parts. And you did a great job. The other thing for everybody, Matt clearly showed himself as somebody to reach out to anytime you want to add some math geek to what you're doing. So I saw you do a lot of adding expressions inside of operations and inside of the modeling side too. So everybody should know you're a good person to reach out to on that.
Yep, that's a lot of what I do.
Yeah, Keith brings up a good point. Strong arm is relevant in any software. There's always going to be pushing the limits of software, and having a solution where you're not boxed out of it is very important. So leveraging the CAD geometry to make surfaces to patch things in, geometry to drive the tool path. Any good shop is always pushing the limits of what their equipment and their software can do. So it's not wrong. It's part of being a professional.
Hey Matt, some of the other good points that you made about using an STL to drive your rest machining, as well as using that STL to do the simulation on is a pretty smart way to do it. I really like that. And your use of folders, as Al had pointed out, is a really good, nice, clean way to keep your projects in order, and you can see which ones you've done already and always go back to. And you also protected some of those toolpaths, so as the model changes or as things change, you can always go back and double check and make sure that they didn't change as well by protecting them.
Yeah,
and,
yeah. I've gotten into the habit of using it quite a bit lately, because it does help really well with keeping things organized.
Speaking of organized, I see somebody asking if we'll make this file available for all of the users, and it dawned on me that if you could just open up CAM samples for a minute, Matt. It's starting to become a little unorganized. We want to get as many files in there as we can. Maybe what might make sense is we'll add a folder for Friday Hangouts at the top there. And this could be the first data set we add. Maybe, Wayne, we can look at going back to some of the previous Hangouts and adding some of the past data sets in there, because I agree it's very nice to be able to reverse engineer what other people have done and figure out how to go about parts. Thanks for the request. Who was it? Diego was asking to get access to this part. So yeah, we'll get it into CAM samples, probably in a folder called Friday Hangouts. So keep an eye out for that.
Very cool. So it looks like our people are agreeing on the STL usage and being able to work with the STLs. Another quick point I'd like to add too, I like when you're doing that contour on the part and you hold the Alt key to be able to select individual lines to be able to project and use that into your in your toolpath. That was another nice point to use a quick key, the Alt key, to select the geometry.
Yeah, very good.
Yeah, I use that a lot.
Well, other than a lot of thanks on the question side of here thing, Matt, I don't see any other questions coming in. I saw a nice little comment that some people using some different 5-axis machines still learned a lot. And so, yeah, even though this is run on a Haas, and we obviously love working with Haas, the concepts are applicable to any 5-axis machine. So with that, Wayne, what do we have up for a webinar next week?
I actually was working and asking if we have Xander Luciano. Was working on a lot of 4th-axis stuff, and he does a lot of automation. When it comes inside of Fusion, he's able to work with the API a lot, and he's done some work with being able to verify and simulate. So it would be great to have a nice conversation with Xander. I think he's also an intern now at Pier 9. Is that right, Al?
His official internship at Pier 9 is going to start a little later this month. So yeah, Xander will be spending the summer at Pier 9 along with one other intern, Sonny. Sonny's project is going to focus on adding to the CAM samples and fixture libraries. So on that note, feel free to reach out to us if you've got work holding files that you think should be shared with all the users, and Xander will be working aggressively on a more development-oriented project. If any of you saw his NC viewer, you know Xander's a very talented young man. So we're excited to have both. Looking forward to having support a webinar. It's good.
Yep, that'll be an exciting one next week.
Yeah.
So with that, guys, Matt, really appreciate your being here. Really great tips. It's awesome to see some of the ways you were able to get this part to work for demo days. And that was really successful. We heard a lot of good feedback from people who visited and went to that demo days event. So really nice job, Matt. And thanks for coming on with us this week.
Yeah, no, my pleasure. Anytime.
Awesome, guys. So thanks for all your feedback too, and we really appreciate getting all that information of knowing how we're going to drive our webinars in the future and how we can get more development for what you guys need to drive your business. So with that, next week we'll see Xander. Have a great week, guys. If you can, please check out our Wednesday webinars. On Wednesday we have our Fast Track to CNC as we get started. So anybody who's new joining us today, if you want a good overview, join our Wednesday webinars. So guys, have a great week. Thanks for joining us, and we'll see you next week.